Alright, now we're going to look at a few questions. And our first question is this one here. The sketch below represents the graphs of f of x. As you can see, this is definitely a hyperbola, is equal to g of x, which is definitely a straight line. Y is equal to mx plus c. Point B is 3, 6, lies on the graph, and the two graphs intersect at points A and C. Right, so let me just copy down these quickly. F of x, 2 over x minus 3, minus 1. F of x equal to 2 over x minus 3, minus 1. And we also have g of x is equal to dx plus e. Let's quickly confirm. Yes. Now we are told that the two graphs intersect at points A and C. Let's point there. And that point is a point of intersection. And we know that at the point of intersection, f is equal to g. What does the first question say? Write down the equations of the asymptotes of f. They're giving us 2 free marks for that. Now, we said that our asymptotes can be read off from the function. Remember, we said x is equal to p and y is equal to q. So these are the asymptotes that we get reading off from here. If you don't want to be confused by that, you can write it as x minus 3 is equal to 0 and solve for x. That would give you the asymptote. Next question. Write down the domain of f. Now you may scroll back, but remember that domain refers to x values, and we said for a hyperbola, your domain is x element of R, and x is not equal to p. But in this case, we know our value for p. P is the asymptote. So we are saying x is not equal to 3. You can easily see it from there. Our graph will never be equal to 3 since it's an asymptote. Right, next question. Determine the values of d and e correct to the nearest integer if the graph of g makes an angle of 76 degrees with the x-axis. Now coming back to our diagram, we are told that this straight line makes an angle of 76 degrees. What does that remind you of? Takes me to paper 2, where we normally deal with analytical geometry, angle of inclination. Remember, we said our angle of inclination is m is equal to tan theta, where this is our theta. We already have, from this formula, our gradient. M is equal to tan 76. If you calculate, you get 4.01. However, they want their answer to the nearest integer. So we're just going to round it off to 4. From this point now, remember an equation of a straight line is y is equal to mx plus c. Even though in this case they gave us dx plus e. So our answer here that we got, which we call m, is in actual fact d. So from here now, we look for an additional point which we can use. And if you analyze your graph, you will see that our straight line passes through the point B is 3, 6. we are going to use that point to calculate the Y-intercept, which happens to be that point there, where the line cuts the y-axis. And allow me to use this format. My y1 and my x1 are this point B that you see. The 3 is going to be my x1, and the 6 will be my y1. I'm going to substitute now here. Y minus 6 is equal to 4 into x minus 3. We'll quickly check. Yes, x1 is 3, y1 is 6. Now simplifying this, we have 4x minus 12, taking the negative 6 over, comes plus 6. We end up with 4x minus 6. This is the equation of g of x. Next question requires us to determine the coordinates of A and C. Let's go back to our graph and identify where A and C are. A and C. There's something special about A and C. Like we said, these are the points of intersection between the two graphs. And if you remember from part 1 of this video, we said that at the point of intersection, the two functions are equal. So we're going to equate them. We form an algebraic equation and solve for x. We will probably get two values of x. As you can see, there are 2 points of intersection. So we'll get 2 roots from that. Right, we have 2 over x minus 3 minus 1. Is equal to g of x, which is 4x minus 6. Now we need to solve this algebraic equation. This is fun. Alright, so we will obviously start by multiplying each term by the LCD. And when I do that, I'm going to end up with this. And we're going to simplify this. Take note that I'm using brackets. Please use brackets in the right places. If you don't use brackets here, you'll end up with something incorrect. And here we're going to FOIL. And then we collect like terms. Our final equation will be 4x squared minus 17x plus 13 is equal to 0. Let me go back to my favorite color. Right, we're going to factorize this. Another alternative is to use the quadratic formula. But I'm going to factorize. So I'm going to use product, sum, factor. This is one method I use to factorize quadratic equations which are not so straightforward, especially if the coefficient of x squared is not 1. So the product here is the A term times the C term. This gives me 52, saying 4 times 30. The sum is the middle term. This is the sum. negative 17. Excuse me a second. Negative 17. And then factor refers to two numbers whose product is 52 and whose sum is negative 17. Just quickly going through my mental maths here, I'm getting 4 and 13. 4 multiplied by 13 does give me 52. But now I want them to give me negative 17. So obviously both of them have to be negative. I'm going to rewrite this as 4x squared. Now I'm replacing negative 17x with these two numbers here. Minus 13x minus 4x plus 13 is equal to 0. Take note that these two numbers give me negative 17. So I haven't changed much here. Right, moving on, now I do factorization by grouping, which I learned in grade 9. Factor out x, I have 4x minus 13, and I factor out negative 1 here. I have 4x minus 13, and I end up with x minus 1. Sorry, I forgot equals to 0 here. And into 4x minus 13, which is equal to 0. Now this gives me two values, x is equal to 1 and x is equal to 13 over 4. Let's quickly go back to the question. Question says determine the coordinates of A and C. So we know that coordinate refers to x and y value. Now that we have the x values, remember A and C are at the points of intersection of G and F. We can take our x values and substitute them either in F or in G. But since I like to make my life easy, I'm going to substitute in G. Remember we said G of x is 4x minus 6. And always remember that G refers to y. F refers to y. So my y value, I'm going to substitute the first x value that I obtained, and I'm getting negative 2. And then this gives me the coordinate 1 and negative 2. Now I'm substituting the second x value which I obtained, which is 4x into 13 over 4 minus 6. Excuse me. 4 into that, we've replaced x with 13 over 4. And a quick calculation will tell us that we will end up with 7. Our second coordinate is therefore 13 over 4 and 7. But we need to make a choice here. We need to decide which one is A, which one is C. Going back to our graph, as you can see from the position of A will obviously be the smaller x value, and C will be the bigger or larger x value. So for our x values we have 1, we have 13 over 4. 1 is smaller, which makes this A, and at C we are done. Right, moving on to the next question. For what values of x is g of x greater than or equal to f? Beautiful question. When is g greater than f? So whenever I see this question, I would like to reinterpret it. Write it in a language that I can relate to. They're basically asking me, where is G above? So they say greater. Where is G above F? And sometimes it helps me to introduce some colors here. There is my F, which is blue. And there is G, which is green. So if I were to rephrase the question, they're basically asking, where is green above red? So I'm going to go to, sorry, not red, but blue. Green above blue. Where is green above blue? So I'm going to highlight or mark off all the places where green is above blue. Starting here. And here. Up to that point. The places that I've marked indicate the areas where green is above blue. So what I need to do now is to write it down mathematically. I obviously need to know the coordinates of this point, which happens to be A. Remember, I calculated A, and I found that x is equal to 1 here. And at this point, x is equal to 13/4. And then this vertical asymptote, we already agreed that this is y, excuse me, its x is equal to 3. So you can see that green is above blue from this point here, which is at x is equal to 1, right up to the asymptote, which is at x is equal to 3. So we can say from 1 to 3. But now we need to decide whether 1 is included, whether 3 is included. Let's go back and check the question. If you look at the question, they use greater than or equal to, which is not a strict inequality. So here we can say greater than or equal to 1. It would be nice to write less than or equal to 3. However, we cannot do that because the blue graph is undefined there. So we will put a strict inequality, leaving our answer as this. This is not the only place where green is above blue. Like we said, at the point C here, green is above blue. And point C is 13/4. From the looks of things, green is going to be above blue until infinity. So what we can say here is that x greater than or equal to 13/4. The final question asks us to determine an equation for the axis of symmetry of F which has a positive slope. Please refer to part 1 of this video, where I give the equations of the axis of symmetry. Fastest way to get them. But in case you find it hard to remember, let me see if I can help you. Remember, hyperbola is written as a over x minus p plus q. The equations of the axis of symmetry actually comes from this part here. Just copy that as it is and write y is equal to x minus p plus q. We're going to have two equations of the axis of symmetry. So you're going to do that, plus or minus. One of the equations has a positive slope, the other is a negative slope. In this particular question, they want an equation which has a positive slope, as you can see. Now, how do we go about doing that? Let's make life easy for ourselves. The function that we're given is f of x is equal to, let me just quickly refer, 2 over x minus 3 minus 1. 2 over x minus 3 minus 1. So what you have to do is just circle this part. This is the part that you have to circle. So your equation will be y. Since we want the equation with a positive slope, it will be x minus 3 minus 1, which gives us x minus 4. We are done. If the question instead was the axis of symmetry with a negative gradient, let's say, for instance, they had said negative gradient. The question wanted axis of symmetry with a negative gradient. We would have done the same thing. Still, you just circle that part. Then you write it down as y equals to x minus 3 minus 1. However, since you want a negative gradient, you just put that part in brackets and put a negative here. Then you simplify to get negative x plus 3 minus 1, which gives you negative x plus 2. Alright, however, we know the question doesn't ask for negative gradient. The question wants positive gradient. Now there's an alternative method. If you are old-fashioned, like some of the people that I know, you would want to do it the old-fashioned way using y is equal to mx plus c. What you need to remember, however, is that m must always be 1. For an axis of symmetry of a hyperbola, m is either plus or minus 1. So in this case, since we want a positive gradient, we know it's y is equal to x plus c. And then we choose an alternative point, an additional point which we'll get from the point of intersection of the asymptotes. We know that this point is 3 and this is negative 1. So this makes our coordinate here 3, negative 1. So we take that and substitute here. negative 1 is equal to 3 plus c, meaning c is equal to negative 4. Then you conclude that y is equal to x minus 4, which gives us the same conclusion as we obtained with this initial method. So, choose you this day which method you're going to use.